Yep, I hear you. The good news is I got a wet on my BRT.
Outstanding. That is good news.
So, Butch, are you thinking having Reed come up the starboard side of the lab, and then he'll avoid the antennas, and then maybe be able to come up on the other side of that thing? Is that what you're thinking?
That's affirmative.
All right, Butch, can you see the WETA coming now towards the port lab struts?
Yes.
Okay, this is where I'm going to definitely need your help so that I don't bang this thing.
Okay. You're about 2 feet from the lab. The WETA is. You can take it to start a port rotation.
But if I do that, how am I looking now?
Now you're like 3.5, 4 feet.
All right, let's see if it's gonna come back. Give me a minute. I'll work on that.
Okay. Nice job.
Okay, now my only concern is, can you see how do my safety tether fare in that?
It looks pristine.
Okay, so
you see that gap spanner to your left?
I do.
If you get to that gap spanner and turn your feet towards me and pirouette around and come up that starboard side, I think that would be perfect.
All right, we'll talk through that in just a minute.
You'll need the fair lead as well on that far side.
Hey, can I unlock this tether you got down here?
You may.
That's much nicer. Okay. All right, I'm just going to keep coming out your way, and I'll need your help with the WETA a little bit and my safety tether.
Okay.
As I start doing these hayakas. All right, so you're recommending that I cross here.
That's correct. Go all the way across until you get to the handrail.
Okay, now, I probably want to turn this way to keep my safety tether clear.
That's correct. Perfect. Looks good. That looks real good. Nice job.
Nice work, guys.
Your safety tether may clear above those antennas from where it is.
Well, we'll take a look. You think, you know what, it's better though if I just drop this fair lead right here. I think it'll be a lot cleaner.
Nice. Nice. Yeah, you hit that PGT from right there. I think you can do it. Actually, if you can hold it, I can do it with a PGT.
All right, just stand by. Let me get out of here. Let me get settled down. Let me check out the work site for a minute.
Absolutely.
And then we will talk it home through. All right, my tether looks good on those UHF antennas. How's the, I think the WSSA looks fine where it is back beside me. All right, I tell you what, Butch, I cannot BRT where I am right now.
Yeah,
because they got the WETA.
Yeah, I can't BRT to where I can get in position, drive the bolt with this one hand.
Okay, so do you want me to try to drive here, just holding?
Yeah, I think that you could drive the bolt right now.
All right, what do we need for PCT settings?
It's a Bravo 3, clockwise 2.
You know, Butch, with a Bravo 3, we got a BRT, man. I don't think I can...
I'm just talking about initially to get it down in. Then from there, I can go from there.
We concur with that plan.
Rick, are you okay? All right, that's good. Bravo 3, and say again, Ricky, the clockwise 2?
Good numbers.
This is Mission Control Houston, a good view of the WETA antenna, the Wireless Video System External Transceiver Assembly. Essentially, this is an antenna that provides helmet camera views for the spacewalkers during excursions outside of the International Space Station. Wiseman is on the top side or space-facing side of the Harmony module along with Butch Wilmore as they work to secure a stanchion or post that used to house a camera system on the nadir or Earth-facing side of the Port 1 truss. That camera that has a degraded zoom capability was removed from the stanchion. It will be brought inside the airlock. The stanchion itself will be the new home for this WETA antenna that was moved from another camera port on the port side of the truss of the station and will be mounted on top of this stanchion a short time from now.
I might need you to dither that thing. There we go. Yep, keep dithering it. Dithering it.
We are now approaching the 4-hour, 15-minute mark in the spacewalk that has been highlighted by the successful replacement of a failed voltage regulator called the sequential shunt unit on the starboard truss of the International Space Station that experienced an internal short back on May 8th, taking down one of the 8 power channels for the station's electrical system. Although no station activities have been hampered since May due to the loss of that sequential shunt unit, the replacement unit was installed earlier in the spacewalk, has been checked out by the electrical systems officer here in Mission Control, is in great shape, and the 3A power channel will be reintegrated into the electrical power system of the station by this time tomorrow.
It looks like it's going down now. Yeah, it is. Yeah.
Yeah, the only problem is that was 6.9 turns, and I got a good green light at 18.4 on the actual torque. Does that sound like what you were expecting, or is it not in there yet?
It's not in there yet. It started, but it's not in.
You might have had a bad angle on that bolt, Reed. Why don't we see if Butch, you hand it off to him and see if he can continue driving with a little bit more over the top angle on the bolt.
All right, sorry about that, Ricky.
That's a good job, man.
Well, it started, didn't it? It started, right?
Yeah, you got it started. That's great.
Ricky, I think maybe more than angles, I think it's just a dithering process here.
Yeah, fair enough.
Bravo 3, clock 2.
I don't think I got it in there, Butch.
I don't think so either. Dang.
All right, so...
put it back. Let's see if I can get it.
That's an option. We also suggest maybe just temp stowing the WETA because it's got to come off your BRT anyway, and that way you can maybe both of you can be BRT'd and work the install that way.
Yeah, that's where we're going. That's a good call, Ricky.
Hang on. Watch out for the...
I got it. You got to take this stanchion, though, because I got to get this.
I'm getting
WETA off me.
Well, the bolt was down. Pop back out. Ricky. You want to let me just try it since I got a BRT down?
Yeah.
And just see if I can do it. Just hold it. Can you hold it before you go through all that?
We were thinking as an option. Go ahead and give this a shot.
Needs to lean towards you.
Yeah, but I'm not BRT'd. I don't have any control at all right now.
Okay. Understood.
If you can hold it because you're BRT'd and you can drive it, that's great. But if not, I got to get rid of the WETA and do this properly.
Understood.
We concur, and we were thinking.
Right there?
We were thinking just taking the WETA and putting it down on the handrail that runs forward from on the lab down by Reed's feet. Just put it on a ret and get it out of the way and let it retract up against and sit there for a few minutes while you guys go ahead and install the stanchion together. That's just one option. You might have a better suggestion.
That's fine.
This is Mission Control Houston, 4 hours, 20 minutes into the spacewalk. As has been the case throughout today's excursion by Wiseman and Wilmore, some bulky bolts hampering some of the installation activities for the crew members. They're continuing to work to bolt in place the video camera stanchion that was removed from the P1 truss of the International Space Station and now is in the process of being attempted to be secured to a camera port on the space-facing side of the Harmony module. That device that you see floating next to Reed Wiseman, actually tethered next to Reed Wiseman, is the Wireless Video System External Transceiver Assembly, or WETA by its acronym. This is a transmitter, if you will, that provides helmet camera views from spacewalkers outside the International Space Station and will be mounted to this camera stanchion or post that has been relocated to the top side of the Harmony module.
Okay. You can let go, I think. And now I should be able to hold on pretty well, Butch.
Okay.
Wiseman was instructed to temporarily tether the WETA in place so he could be freed up to assist Wilmore in securing the bulky bolts for the stanchion on the top side of Harmony.
this is just a tough work thing.
Yeah, it sure is.
Push against the boat, and I push myself away.
Yeah, tighten your VRT down as tight as you can get the top part right there.
Yeah, it is tight as I can get it. If VRT was on the right, it'd be perfect. That ain't gonna work. Wrong side for me. You want to take my PGT and let me hold it and see if you got a better shot?
From where I am, can you hold the stanchion?
Yes. Okay.
Again, but I gotta reconfigure again. Here, hold the PGT. Sorry, man.
All right. It's a tough one. Both just in the wrong spot for where our handholds are.
And I'm still not in a great position after all that work. So even with your hand on that handrail on your VRT down, you cannot get on your PGT very well right now?
Try.
It's hard to tell if that stance is straight up and down. It seems like it needs to lean towards your head a little bit. Seems like it needs to lean about there. Okay, keep driving.
Yeah, there.
I don't think we're even into the soft dock yet, Butch.
Push it.
Nope, we're not even into the soft dock. So we got to get this thing off, get it into the soft dock.
And it will take a bit of force to get it in the soft dock.
All right, yep.
Hey, Reed, you need to watch your feet on the WETA.
Yeah, bag on it, okay.
Yeah, guys, I'm wondering if we ought to rethink this just a little bit and maybe move the WETA down a little bit more on the starboard nadir side, get it out of the way, and then see if there's what body position would work to get this done. Because it seems like neither of you are in a position that you're really happy with right now, and if there's just take a step back and see what we need to do.
Copy that. Let me get the WETA. I'm just going to string another wet across the lab here, across from node 2 to the lab. Thanks for watching that, Ricky. Dropped out of my scan.
Yeah, no worries. And just let us know the config you have with what RETs you have on there so we can help keep track for you.
As we approach the 4.5-hour mark in the spacewalk today, again, you can see the EVA, or the wireless video system transceiver assembly, this transmitter that provides helmet camera views from spacewalking astronauts.
If Reed took his feet a little bit nader down in between the node and the lab and was able to get up close against that, kind of on that handrail on the circumference of it, and get up close and even use the tether going across to kind of cinch himself up close with the PGT.
Happy that, Reed?
Yeah.
Not entirely. Let me just try going all the way down here.
The International Space Station is currently flying 260 miles across the west coast of France.
That's just a suggestion. You have some room there, and you can actually get close to where you're trying to work. And we think you're in a better position now than you were, so you feel free to try this. And you got your right hand right there, so you might be able to apply a bit more force. And one other option is just spin 180 out and kind of wedge yourself down in there and get up close.
The EVA has been temporarily stowed with tethers so that Wiseman can apply force and working in tandem with Butch Wilmore to try to secure the camera stanchion onto the top side of the Harmony module in what is now known as camera port 11.
I'm giving it my all.
No, hold on. Without turning, let's get it. We start turning.
Yeah. I have tried that many times even before you arrived, but we try it again.
We've lost our television downlink capability as we move through the tracking and data relay satellite system. We're about 23 minutes away from reacquiring that television signal. We'll be following the spacewalkers on the space-to-ground audio channels.
I don't think I'm getting very much force into it. Okay, let's go to the Ricky message. You're going to have to really help me on these antennas.
Okay. Just try to stay as close to node 2 as possible. Okay. Put your feet up over the EVA. Feet up over the EVA.
Stand by. I'm with you. We get the safety tether down there. Hopefully it'll stay. And now let me think. I'm going to wrap my tether all the way around me here. We go like this.
Clear the EVA.
Okay, watch my feet going down this.
Yeah, stay to your, yeah, just like that. Perfect. Now you're clear of the thing.
How about those UHF antennas behind me? I don't fit down here. Dang nabbit.
It looks from my vantage point that you're clear. Yeah, I'd say you're probably going to get close to them.
How's it going, guys?
Not much better, Rick. It's still just a really tough angle, regardless of where we are, to get this thing to drop into the soft dock and stay.
One other suggestion was kind of what you were getting at earlier with your feet kind of pointing
Stand by.
Station forward.
Let's see if that's in there.
Get your BRT up against on the handrail, and you actually can use your left hand holding onto the handrail and using your right hand to really put the force into the bolt.
Working out.
And what setting?
Bravo 3. Block 2. Try it one more time.
I think it's going in. I don't know though.
Well, the whole thing is just twisting me around.
You driving? Because I think it's going in. I
I'm
can't
driving.
tell.
Driving. That's a lot lower than it was before.
How many turns, Ricky?
17.
All right.
Yeah, looking 17 to 18.
Hey, that thing's in there.
I can't read it because of the sun's in my eyes. Can you see it?
I don't know where you started at. It's 18.3 on the chart, but it says 39 turns, so I don't think you reset the turns.
No, I did.
Copy 18.3 and a green light. Good work, guys.
That's exactly right.
Well, at what expense? I hope I didn't damage that weather.
How about a good pull test as well on the stanchion before we start releasing stuff?
This is Mission Control Houston, 4 hours, 35 minutes into the spacewalk. Again, persistence paying off, the crew exercising a bit of muscle, and through the combined efforts of Butch Wilmore using a pistol grip tool and the manual force of Reed Wiseman assisting to apply pressure, the camera stanchion has now been bolted into place on the top side of the Harmony module of the International Space Station.
We were thinking maybe just give a little bit of a pull on that stanchion to make sure we are truly engaged before we start releasing rets.
We did that, Ricky, and I'll do it again. It feels like it is in tight.
Good words. Good words. So let's go ahead.
Not going anywhere.
Copy that. So obviously the next thing is we need to retrieve the WETA and get ready for the install. Butch, I have some steps. Before we get the WETA, why don't we go ahead and release the small ORU bag and temp stow it. And then we're going to go ahead and make the connectors on the connector panel for CP11.
Okay, we'll do that, Ricky.
And that connector panel is node 2.
Got it.
With the television camera stanchion now secure on the top side of the Harmony module, the next step will be to install the wireless external transceiver assembly on that stanchion. That WETA, if you will, was retrieved from camera port 8 on the port side of the truss of the International Space Station, will be relocated to the top side of Harmony to provide better visibility for better coverage from helmet cameras for future spacewalking astronauts. Reed Wiseman will be sent back out to camera port 8 to retrieve a camera itself that...
Yeah, I agree with that.
To install a brand new camera onto camera port 8 that will provide good views for visiting vehicles and for the robotic installation of vehicles onto the International Space Station in the future. Camera port 7's television camera has a degraded zoom capability. It was removed from the nadir or Earth-facing side of the Port 1 truss a short time ago and brought back inside the International Space Station. The brand new camera that is to be installed a short time from now on camera port 8 out on the port truss of the station will provide, as we said, better views for visiting vehicles approaching the International Space Station.
All right, Butch. Where do you want me to leave this WETA? Can I leave it right here? Or you will come around and get it? I think you can come around, get it, install it, and then clean this up.
Okay. Yeah, leave it there.
Hey, I have a suggestion, guys, as well. We were just talking.
Next for me, Ricky.
We were thinking if, since Reed has his RETs already on the WETA, he can go ahead and pick up the WETA and just install the jacking bolt. And that way he can retrieve his hardware, then head off to get the failed camera group and let you do the rest of the cleanup and the other 2 bolt installs. What do you think about that plan?
Sounds good to me.
All right, I'm here. Get up here and I'll guide it in.
Okay, why don't we go ahead and do that then? And so, Reed, you can start getting the WETA and gathering up your RETs, get it and put it back on your BRT and head back up and get in a position to install it. And I'll talk you through the install of the jacking bolt. You can retrieve your tethers, your RETs, and then you can head off for the failed camera group. And meanwhile, I can have Butch work on some of the connectors.
Spacewalk communicator Ricky Arnold here in Mission Control, talking the crew through a slightly revised series of steps to try to maximize the time available to them to complete their tasks today.
And I'll go in.
The failed camera group he referenced is the camera that was removed earlier in the spacewalk from the nadir side of the Port 1 truss. Its zoom capability has failed. It will be brought back inside the station, and a new camera to be installed on the zenith outboard side of the Port 1 truss that you see on the right side of this graphic on camera port 8.
You're going to use the scoop for the install. Just remember to tether elsewhere into the WETA because when you go to actually drive the jacking bolt, you have to remove the scoop to drive the bolt.
Right, we are rented right now through the WETA itself. And we just want to know, can that scoop stay with the WETA, or does that scoop have to come back with me? Can it stay with Butch, or does it have to come over to me?
Whatever works for you guys.
That scoop can stay with Butch.
We concur.
Butch, why don't you rent to that scoop and take it off?
I'm ready for the scoop. Want me to remove it now?
Yeah, you can remove that scoop and keep it on your mini workstation.
All right, I got it.
Okay, and then when you're done with that jacking bolt, you can release, with a good bolt test, you can release the rat on there, but we got to dry that bolt first.
And Reed, I have settings when you're ready for the jacking bolt.
I'm ready for PGT settings.
Okay, it's going to be Bravo.
You're ready.
Bravo 1, clockwise 2. Looking for 23 turns.
Bravo 1, clock 2, 23 turns.
Ricky Arnold instructing Butch Wilmore on the settings for the pistol grip tool that he will use to install what is called a jacking bolt. That's a bolt to further secure the camera stanchion
setting.
As well as to provide the proper settings for the installation of the wireless transceiver assembly on top of that stanchion that now resides on the space-facing or top side of the Harmony module. The spacewalk that began at 7:16 a.m. Central Time, now 4 hours, 43 minutes in duration. The crew having completed the major tasks so far, that being the replacement of a failed voltage regulator called the sequential shunt unit on the starboard truss of the International Space Station. The new component has checked out in good fashion by the electrical systems officer here in Mission Control. The 3A power channel that was taken down by the old sequential shunt unit's failure back on May 8th, that 3A power channel will be fully reintegrated into the power system of the space station by Thursday morning.
Okay, when you get to 20,
You're just running 23 turns, right, Butch?
Yeah.
23 turns, and then we'll give us the running torque and turns, and we'll give you the PGT setting.
Okay. The turns were at 40 because the first ones did not catch, I guess. I'm ready for the PGT settings.
Okay, say again.
That running torque first.
Yeah, say the running torque and turns.
Yeah, the torque was at 12, and the running turns was 40, but the first one didn't grab, obviously.
We copied the turns were 40, but the first one part didn't grab. Do you have a running torque for us?
That's what I said, it was 12.
Okay, copy 12. Stand by.
All right, weird angle. Done. Yeah, and it's just like the sun, this light's right in my eyes.
Which, did you run that one until it torqued out, or did you just run it 23 turns?
I ran it 23 when I counted 23, but it started, but it wasn't going initially.
Yeah, but the PGT did not torque out, right?
No.
Okay, you stopped before that.
Yes.
Those are good words, guys. Stand by 1 second.
How you feeling, Ray?
I'm doing all right, man. Not quite ready for cheese grits yet.
Me either, I'm good. What do you want to do, Ricky?
Please stand by, guys. Appreciate your patience.
Yeah.
Hey, Butch, can we confirm you got the number for the max running torque from the upper right-hand corner of the PGT display?
Yeah, it's already been reset, Ricky.
Was it 12?
Yes, that's what I saw. Is that high?
Okay, no worries. Okay, guys, let's go ahead and run it at Alpha 1 and complete the rest of the turns. So we did 23, and let's just do it until it torques max turns.
Okay, Alpha 1. Block 2. Block 2, Ricky.
That's affirmative.
Again, Reed, this light's right in my eyes. Can you see what that says?
You went 0.05 turns and you got 2.4 actual torque.
0.4.
This is Mission Control Houston, 4 hours, 49 minutes into the spacewalk. Reed Wiseman working with Butch Wilmore to install the wireless helmet cam transceiver assembly on to the newly installed stanchion on the top side of the Harmony module of the International Space Station. Wiseman will bring the degraded camera that was removed from the nadir or Earth-facing side of the P1 truss back into the Quest airlock, and at the same time retrieve a new camera to be installed on the zenith or space-facing side of the Port 1 truss in what is called the Camera Port 8 location. A good graphic showing the various work sites where this television equipment is being moved around to. All of this TV camera relocation has a dual purpose. First and foremost, to clear a pathway for the robotic relocation of the permanent multi-purpose module from its current home on the Earth-facing side of the Unity node of the International Space Station to the forward port of the Tranquility module in the summer of 2015, as well as to provide better television camera views for robotics and other situational awareness at various points of the truss of the International Space Station for the future arrival of visiting vehicles.
We like that plan. Thanks, guys.
All right, I'm ready for the weather.
All right, you can release my wet. My wet. All right, I got it. Thank you, Butch.
Bet.
Okay, Reed, you're going to, when you have your RET back on your mini workstation, you're going to translate to the failed camera group, and you're going to stow that on your BRT and translate to the airlock. And give us a call when you get to the airlock if you have any questions between now and then. Butch, we'll have a settings here for you shortly.
Okay. Thanks for the help, Kyle.
Yeah, absolutely. I'm glad we got this point at least.
Ah.
All right, Butch. We're going to ask you to back out that bolt, the jacking bolt, Bravo 1, counter 2 for 5 turns, and I'll have a handover here.
There's 5 turns, Ricky.
Okay, 5 turns at Bravo 1, counter 2, standby. Can we get the torque in the upper right-hand corner from on the display?
It says low torque on the bottom and top says 7.
Okay, copy 7 from the upper right-hand corner.
That's firm.
All right, Butch, we'd like you to go ahead and set your PGT to Alpha 7, clockwise 2, and go ahead and drive the bolt until you get max torque.
Alpha 7, block 2.
And we're back WVS with you guys.
Copy that, Ricky. Thanks.
Almost 5 hours into the first spacewalk in his career, Butch Wilmore, EV2, extravehicular crew member number 2, wearing the suit with no stripes, affixing the wireless external transceiver assembly, or WETA, to the camera stanchion on the top side of the Harmony module of the International Space Station. Top side, of course, relative in the vacuum of space, but this would be on the space-facing side of Harmony. Wilmore scheduled to conduct 2 additional spacewalks in January with NASA astronaut Terry Virts, who is scheduled to be launched in late November in a Soyuz vehicle from the Baikonur Cosmodrome in Kazakhstan with Russian cosmonaut Anton Shkaplerov and European Space Agency flight engineer Samantha Cristoforetti. Wilmore will become the commander of the International Space Station for Expedition 42. He will take over command from Russian cosmonaut Max Sarayev on November 8th. Expedition 42 will formally begin with the undocking of the Soyuz vehicle that will bring Sarayev, Alex Gerst, and Reed Wiseman home on the evening of November 9th U.S. time, the morning of November 10th in Kazakhstan.
All right, Butch, we're ready for you to drive the outer bolts. This will be one of the deals, again, where you give us the running torque. It's going to be Bravo 1, clockwise 2, and you're going to drive the outer bolt only 5 turns. Give us the max running torque and the number of turns, and then we'll give you another configuration for finishing this off.
Bravo 1, clock 2.
On the aft bolt, 5 turns.
5 turns. There was 5 turns, Ricky, but it's not going in. Hang on just a second. Let me try it one more time. Pushing in on it. There's 5 turns, Ricky. The green light.
Okay, what was the running torque?
0.5. 0.4. Ricky, I think on that very first bolt, I think I mistakenly read the top left program for 12.
Okay, copy that.
No, that created a...
Okay, copy that. So, and you said 0.4 for the running torque?
That's correct.
Okay, stand by 1. All right, Butch, for that bolt, it's going to be alpha 1, clockwise 2, and you're going to turn it 2.5 turns or until torque, and then you'll report the final torque, turns, and lights to us.
Alpha 1, clock 2. Three turns, 2.3. Good green light.
Okay, same deal on the forward bolt. It's going to be Bravo 1, clockwise 2, 5 turns, and give us the same information.
Bravo 1, clock 2.
Good readback, Butch.
5 turns. Yeah, it's torquing out after about a half a turn.
We have now crossed the 5-hour mark in today's spacewalk by Wilmore and Wiseman. A good view of Butch Wilmore as he continues to secure what are called jacking bolts for the wireless transceiver assembly on the camera stanchion, now affixed to the top side of the Harmony module of the International Space Station.
We're happy with these bolts the way they are. So we consider the install here done with the exception of the connectors and caps, and just want to pick up with you once you get your PGT installed and get back down and you're ready, let us know and we'll pick up with the steps for the connectors.
Okay. He's in. Ready for connectors. Copy?
Yeah, Butch, so let's pick up, did you guys get the connector panel and the MLI? Did you find that yet over on Node 2?
Yeah, it's right below me.
Okay, copy that. And have the caps been demated from that panel?
Negative.
Okay, why don't we go ahead and do that?
Ricky, I'm going to take my red off the
Yeah, that's fine, Butch. Perfect.
Okay.
How you doing, Reed? Looks like you're getting close.
Yeah, it's slow going.
Take your time.
I'm getting close.
So you're going to demate the J2, J3, and J4, Butch, and then we're going to take those caps and install them on the stanchion dummy panel.
Okay. All set. J2 first, is that all right?
No order, just we'll make sure they go to the right one, that's all.
With the wireless video antenna now securely affixed to the camera stanchion at camera port 11 on the space-facing side of the Harmony module. Wilmore will now secure a series of electrical connectors to provide power to that newly relocated system.
J2 has been moved. Going for J3.
Okay, copy that. So it was removed and installed, the P2?
That's correct.
Okay, copy that. And the FOD, no FOD issue?
No FOD.
Okay, copy that.